Welcome you all. In this session, we are going to discuss the load flow analysis by Gauss-Seidal method. Outcome: after successful completion of this session, the student would able to find the solution to load flow problem using Gauss-Seidal method. So, the load flow equations are simultaneous nonlinear algebraic equations, and so explicit solution as are not possible. The solution of nonlinear equations can be obtained only by iterative numerical techniques. So, the following techniques, that is Gauss-Seidal analysis or Newton-Raphson or even fast decoupled load flow method, can be used to find the solution for load flow equations or load flow problem. So here in this session we are going to discuss in detail how this load flow solution or load flow analysis is done with the help of Gauss-Seidal iteration method. As I told, we have three methods: Gauss-Seidal, Newton-Raphson and fast decouple. In this session we are going to discuss in detail about Gauss-Seidal. So here in this slide it is illustrated with the help of flow chart. So initially the values of buzzers are readed. So read the system data, tolerance level and convergence value, that is the acceleration factor epsilon, is need to be readed. After getting those values, form the bus admittance matrix. Assume the initial bus voltage as Vk0 is equal to 1 less than 0 for k is equal to 2, 3 up to n. So this is the second step. So in the step 3, set the iteration count I is equal to 0. Iteration value is represented by I. Next, the convergence criteria, Vmax is equal to epsilon naught. And next, set the bus count. Initially we set the iteration count. Now you are supposed to set the bus count as k is equal to 1. Once you set the bus count, now you need to check whether the bus is slack bus or not. If it is not a slack bus, compute Vi k plus 1, that is the new voltage value. So the new voltage value is Vk I plus j plus 1 is equal to Vkj plus a Vkj plus 1 minus Vkj. So calculate the change in voltage. So how will you calculate? Just you need to subtract these two voltages. So del Vkj is equal to Vkj plus 1 minus Vkj. So in the previous step you calculated Vkj, in this step you calculated Vkj, and the next step is you need to calculate Vkj plus 1. Now you are supposed to calculate the change in voltage, that is del V, that is just you need to subtract these two values. Del that is del Vkj is equal to Vkj plus 1, that is now the previous step, minus the voltage you attained in the next previous step, that is Vik plus 1. So now increment the count of k is equal to k plus 1. K is nothing but the bus count, right? So you have chosen the first bus. Now you need to increase the count of bus by 1. So now the bus becomes now again. So for slack bus we do these things. If it is not a slack bus, directly not a slack bus, we did these steps. If it is a slack bus, directly you can come to this step. If k is less than n, next you need to check whether the k value is less than n. If it is less than n, further compute that del V max value, maximum change voltage, which is equal to Vkj plus 1 minus Vkj for k is equal to 2, 3 up to n. And again you need to check the change in voltage value is less than the acceleration factor epsilon. If S, then you need to calculate the line flow, line losses and slack bus power. If not, then you need to set that I is equal to J plus 1. Next you need to set that I is equal to J plus 1, and you can again directly go to step here, that is setting the bus count. So on setting the bus count k is equal to 1, you get this value. So this is how the flow goes on for Gauss-Seidel method. For load bus calculation, Vp k plus 1 is equal to 1 by Ypp. Y represents the admittance matrix, and then Pp minus jQp by Vpk minus summation q is equal to 1 to p minus 1 Ypq Vq k plus 1 minus summation q is equal to p plus 1 up to n Ypq Vqk. For generator bus, calculate the value of q and Qp k plus 1. So the Qp k plus 1 equation is given, so you need to calculate whether Qp calculated k plus 1 is within the limit of Qp. If lies within the limits, then P remains as PV bus, otherwise it is changed to load bus. Calculate del for PV bus and for P Vp k plus 1 equation. Acceleration factor can be used for faster convergence. Calculate the change in bus voltage del V, and if del V is less than the epsilon, that is your acceleration factor. Find the slack bus power, otherwise increase the iteration count, and for slack bus power is equal to summation Sg minus summation Sl. Thank you.